الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/GDG-MENA.
100%. Google Translation apps. Yeah. All right, perfect. I'm good to start. Well, welcome everybody. Thank you for coming today. What I'll be discussing today will be the topic of machine learning for the non-technical individual. I know it can be sometimes interesting considering that quite a lot of us are coders, but one thing I've noticed, especially since I started my career in programming, is things are getting easier and easier to build. I'll show some example today of, when we were building an ML model, there was a lot of coding involved, where it would be JavaScript, Python being one of the more popular languages. But as the years have passed, and really just 5 years, you're now seeing user interfaces that are actually being able to build production quality models. Before, I always saw them as an interesting way to experiment very quickly, build a logistic regression model, see what it does. Okay, logistic regression is the right algorithm. But now I've seen, especially where I work, we're actually building a lot of these solutions without actually having to write a line of code, which for me, as I love coding, I don't really enjoy. But it is the way the future is heading, and I think it is possible. But the great thing about it is it's giving the ability to access AI to a lot more people, because there are some very great ideas, but they lack the technical skill. But now they don't really need that high-level technical skill. So a quick introduction for myself. My name is Francisco Quintana. Most people just call me Cisco. I'm a lead machine learning engineer from Ajira Futem, mostly working at the Carrefour team, so the supermarket. Been working with Google Cloud for about 7 years. I have 2 certifications, data engineer and machine learning engineer, and I'm also a Google Cloud authorized trainer. So if you guys want any tips on the exam, please feel free to ask, and I'll try to prepare you the best I can. But today's topic is now about seeing how you don't need a high-level technical skill to build some very sophisticated models. So the agenda for today is to introduce you guys a little bit to ML. We're not going to spend too much time on this, but just to refresh everybody what is machine learning. Then I'm going to show you a technology called AutoML, which is a technology that Google created. Name is slightly different these days, like Vertex AI, but it's still well known as AutoML. It's going to actually just be a user interface where we're going to be able to build models from classification and regression using tabular data, or building models using images as well, and eventually you can get it to text. Then I'll demo how this model works. It actually takes quite a long time, so as it's working in the background, I'm also going to present to you Bigquery Ml. How many people here have heard of Bigquery or worked with Bigquery? Great. So Bigquery is actually a SQL data warehouse solution provided by Google Cloud. And it's really interesting to see that, in the past, I found a lot of people have the experience with SQL. So I meet a lot of data analysts, database administrators that can write very good SQL code, but they needed to pass it off to a data scientist or an ML engineer like me to actually build the model. So they would prepare training data sets and say, I want to predict where my revenue is going to be 1 year from now. So they want to do a forecasting solution. What Bigquery ML started to offer people was the ability to build these models just writing SQL. And SQL generally is an easier language to pick up than Python, Java, or R. We're also going to run through a demo of Bigquery ML. Spend quite a little bit of time here showing some of the capabilities. When I first started working with Bigquery ML, I didn't see it as a solution for production-ready models. But now I can tell you that I've worked with probably 10 multinationals who have actually used Bigquery ML for building their production-ready models. Before, it was just an interesting way to experiment and test some things out. So let's talk a little bit about machine learning. Some of these slides I use in the Google Cloud training. So if you have been to a Google Cloud training, this would look very familiar to you. But essentially, machine learning is a way to use standard algorithms to derive predictive insights from data and make repeated decisions. Basically, a very fancy way of saying we're taking some data, we're training a model using a certain algorithm, and we're having it make predictions. So we're always going to need these key components: data, algorithm, the insights, and then have it make a decision. I always say each model should actually be providing something useful. One thing that I find a lot when I work is there are a lot of great ideas, but if they're not actionable, there's no need to pursue it. Yes, the model can tell us something interesting like who's going to churn, but if we cannot actually impact the customer in some way by sending a promotion, communication, there is no real point in moving forward with that. But it is now very accessible to other things, and a lot of the technology that we use, we know that there's ML models working in the background. So if we take a look at the stages of training the ML solution, we know that we need some sort of training data, which could be if we're trying to predict exactly what the object in this image is: a cat, a dog, a car, or an apple. We have our labels, and the images are an input. So here's our training data. Now from here, what we do is we pass this training data to our model. In this case, it looks a little bit more like a neural net. So here's where our model will start applying some sort of functions to understand what's actually going on. And then it'll start to make tiny adjustments until it can figure out what the output is. So next time we pass an image of a cat without the label, it should be able to figure out what the cat. So we know we're always going to need a training stage. And for all of us that have worked before with any sort of machine learning, we know that the data pre-processing step is probably the step we're going to be going to spend the most time on. It's actually not going to be so much a modeling step. So here we see the example of that, and I'm going to show you now how in both AutoML and then BigQuery later on, how we can do some of these data pre-processing steps to start training our model. And the great thing of using a technology like AutoML, you'll see later, is that some of the stuff is already trained for you. So you can actually just piggyback off that and then add your own images later, but they've already provided some training for you as well. So the next stage is to make a prediction. So we know that we would pass it an unlabeled photo of a cat. Hopefully we've trained it well enough before in the past. We've evaluated our model using whatever metrics we think is best: precision, recall, F1 score, probably a confusion matrix, to be honest. And then we'll see how well it did the prediction. If it successfully predicted it, we know we're ready to move on. Now, we have to focus, usually data scientists have to focus on the training and inference stages of an ML model. So we have to make sure that the training is actually done correctly. Images are correct. We don't have mislabeled images. We have plenty of variations of what a dog is. So when it encounters an image that it hasn't seen before, that is also a dog, it can correctly infer that it is a dog. When we look at this pipeline right here, we can say that the images are stored in some sort of cloud solution, right? Then it goes into some sort of modeling solution where we'll do the data pre-processing and everything. And then we pass it into our model, which in this case is represented by TensorFlow, and then it makes its prediction. So we're actually using a couple different technologies here. Some sort of storage solution, which is, say, for argument's sake, is Google Cloud Storage. Some sort of pre-processing solution, and then our model right here, there. What you're going to see later is that all this, with the two technologies I'm going to show you, can be fit in just one solution without having to exit out of it or move stuff from one place to another. And you'll see how it's going to be quite easy to do without having to write very complex code. So we know that Google applies machine learning to a lot of its products. These are just a number of them. And what we're going to do now is see how some of these products can actually be built without actually having to put any sort of writing any code like in Python and R, just using either user interface or SQL, which quite a lot of people know. And I think one interesting thing here is when we look at building ML models, you know, before we needed like a Python programmer to do it, a data scientist to do it, somebody with a degree of technical experience that can actually write the code out. But we're no longer there. So one thing that I like to show is, you know, when I started, it was probably even more complex than this. I was writing code that looked something like this, right? Python, write some code, and output something. Now we're actually going to get to the point where we're not even going to have to touch any sort of Python code to actually build a good quality model. So one of the tools that's going to help us do this is called AutoML. AutoML is a solution created by Google. It sits inside the Google Cloud infrastructure. And what it's going to do is it's going to allow us to build this without actually having to spend too much time creating the models, like writing out code to create the models. So what are the benefits of AutoML? Well, you don't need a lot of ML experience. So it's always strong to know the theory, but you don't need that much to actually build a well-performing model. You'll see in the user interface that you just need to pass it the data it needs, and then from there you can move on. You can also create your own custom models. So AutoML will come with certain algorithms that are available to you. Logistic regression would be one, but now you can actually create your own models and algorithms and store them in AutoML and deploy them from there if you want something if you want something more custom than what Google provides. Simple to use, as you'll see, which has just a nice user interface, and it actually can create very high quality outputs. I can tell you right now, for some of the projects I work on, we actually use AutoML to put some models in production that are actually impacting you as you shop on the Carrefour site or as you're actually visiting one of our stores. And, you know, to think about like 7 years ago, that probably wouldn't have been such an easy option to do, but now we're making it available. Google has made it available for us to do. And obviously there are other solutions in the market that let you do that as well. So we're now, the process that I showed earlier can all be run on AutoML. You'll inset your data set, and you'll see how you can do that by putting it in Google Cloud Storage or direct uploads. You run it in AutoML. Remember before I was saying that we had like a model stage, we had a pre-processing stage. Well, now AutoML can actually all do this for you. And generally, automatically, it'll try to figure out what the feature is supposed to be, numeric, categorical. It'll do the one-hot encoding for you. You don't actually have to call any sort of library to help you do that. It'll take care of nulls for you if you have nulls in your data. And it's basically doing all the steps in data pre-processing that used to take up a lot of our time. And then from there, what we do is we start training our model, same steps as before. We deploy it, and then we serve it. Great thing about AutoML is that we can actually just deploy it inside there, have the model there, and then we just ping it via calling the API, or we can set up batch predictions if we want to not to have like an online prediction system. And then we can now have a fully functioning model that didn't take that long to code, and then have anybody with the experience doing it just move around in the UI and make the adjustments and suggestions. Any questions so far? Cool. So let's actually take a little bit of a demo. Let's go to Google Cloud. And what we're going to do is we're going to start looking at how we would do this in AutoML. Now, I've actually created this a little bit before because sometimes these solutions take a little bit of time to build. Just to give you guys an example. Some of these I started yesterday and they only finished this morning. So I actually had built some ahead of time to make sure that we actually have access to it and we're able to work with it. So inside the Google Cloud platform, we can see that we have all the different products in there. It used to be called AI Platform Notebooks, but now it's generally being called Vertex AI, but you can still access it by going to AI Platform Notebooks. So in this case, I'll go to Vertex AI. Once I'm there, I'll be taken to my dashboard. What does this dashboard give me? Well, it gives me the opportunity to see what data sets and models and predictions that I have deployed. You can actually select your region to see where you want your infrastructure to be, right? So if I want my computing processes to be located in the United States, Iowa, I can actually just put it in here. If you have any sort of requirement of where your data needs to sit, you can actually have control over that. So we can see that I have some data sets in here. So this is how I'll train my model, which models have been created so far, and which predictions I've created. And then it also gives you a few errors to let you know what's actually going on. So the first step is I want to create a data set. So I've defined what my problem is. So I'm going to click on the data set. Here, I'll just give a data set name. I'll just give it GD developer group demo, and I'll put 2022. Now what AutoML is giving me is, okay, what type of data am I going to get and what's the objective? Are we trying to do image classification? Are we trying to do multi-image classification? Object detection or image segmentation? So this is if we're trying to tackle an image problem. But we can also select tabular data. So what are we trying to predict here? Are we trying to predict if a user is going to churn and I'm going to give it, let's say, 7 independent variables and then try to figure out the dependent, which is churn? I could just pass the tabular data there. Or am I trying to forecast a customer lifetime value? We can do that as well just by passing a CSV, or we have the forecasting option. We can also do text classification, text extraction, and text sentiment. So if I pass it a bunch of negative comments from a social media feed, it can actually do a sentiment analysis and figure out if the comment was positive or negative, and it also give you back a magnitude score without actually having to write a line of code. So it's actually getting quite powerful what you can do. When I actually first started working with AutoML, you only had the option of image classification. Now you're getting all the point to text. And then finally, video. So video action recognition. Is the person making a certain action like dunking a basketball? What are some of the elements in the video? Like if I show it a football game, will it be able to recognize the ball? Will it be able to recognize the pitch? Will it be able to recognize the player, the goalpost? And then video object tracking, as objects move throughout the video, recording the timestamp. So all these things that you probably had to open up a library like OpenCV, maybe a TensorFlow library. Now it's actually all being done via user interface. So today I'm actually just going to show a little bit with the image classification. So we're going to just select a single image classification. You do have some advanced options here, but not really necessary at this stage. What I would always say to people is when you're thinking about your project, you need to think about what region your data is going to sit. So if my images are going to sit in the United Kingdom, I probably don't want my region where I'm actually running this process to sit in the US Central. So in this case, I'm just going to put it in US Central. You're going to... Yes.
Okay, so I basically work as an NLP engineer. So I deal with machine learning models for text a lot. And one of the projects that we worked on was phrase extraction, basically, with one of our custom definitions of what constitutes a phrase. So we obviously had like a tag data set that we were building ML models on. Is that something we could train here as well? Because over here I saw like text classification, sentiment analysis, text extraction, and so on. But can we set like custom definitions as well of what we want our output to be, or does it have to specifically fit into?
If you're working with essentially what I would call like the cookie cutter version, like the version that's already kind of built, you just give it what the output will be. But if you're building your own custom model that you can deploy in AutoML, then you actually can define it how you want the output to be.
Okay, so we're not restricted.
You're not restricted, but yeah, you wouldn't be restricted, but there'll probably be more limitations than if you were to work with like your own a library inside of like a Python notebook. But you can actually do it right here. So I'll just jump real quick to, you can actually upload your own models as well. So if you had a model and then the output would be whatever you want the output bit, you can actually import it inside here. I will need to double check for you, but I'm pretty sure most of the models will have to be built on TensorFlow. I don't think you would be able to use another library, but I will double check that one for you. Cool. So let's go back to dashboard and let's create a data set. So let's go back here since I didn't save it. And we're going to click the create option. I picked image classification, single image, great. So now that we we're in the process of creating our data set, it's going to ask us where do we want to import our images from. So you can actually go to Google Cloud Storage and you can actually select the path where your images will be. So what I had done before is that I actually had uploaded all these images because, you know, in a live demo, it might take a little while and things could get frozen. So I would actually say that here would be some of the images I would actually be training in. Now, one very interesting thing, and I'll open up this in just 1 second so you guys can see. So if you just bear with me 1 second, and I'm just going to jump around screens a little bit right now. This is one of the images I have in Google Cloud Storage. So let's define what the problem is. We're trying to define what is the type of cloud inside this image. So we'll have 3 different versions of the cloud. Now, this image sits inside Google Cloud Storage, which if you don't know, it's basically just an online storage solution. I've uploaded the image in there in its own folder. So all the Cirrus Cloud images would all be stored in here. So if I just take 1 step back, all the other Cumulus Cloud images and all the other versions are actually stored in their own folder. Why do we do it this way? Well, we can simply say this is essentially the labeling part, right? So it knows that every image inside this folder is a label. So I don't have to individually label the image. As long as it's in this folder, it knows that all those images are labeled. Now, instead of me having to put this image and point to each folder, what I can do is I can actually create a CSV in AutoML, and it'll look something like this. I don't know if you guys are like me, but when it's some CSV, I prefer to open it in the text editor. And let me zoom in a little bit. And I have a feeling that the other people won't be able to see this online, but basically what it is the path of the image. So the CSV will actually just contain the full path of the image. So I don't actually have to manually insert every image. I can just say, here, take the CSV, and these are all the images. And what you see right here is the label. So it knows that this image represents Cirrus Cloud. Same way here, this image represents here. So if I just put in a CSV, I don't have to drag and drop and click in everywhere. It's just one CSV and it locates everything. So that's basically what it would do if you do the data CSV option, which is a lot quicker. So jumping back over here, what I did in the data CSV option, and let me just see if I can somehow open this in Chrome, just because I would like people to see what the CSV looks like. No, never mind.
It doesn't appear on the screen.
No, I for some reason I can only share the tab. It doesn't let me share the screen, but I'll share an image of that in the chat in just a bit. So we're now back here. The CSV contains the path, and for the people that couldn't actually see it, the path would look something like this, where you'll have the path to your Google Cloud Storage bucket, and then separated by a comma, the label of the image. So once you're there, you're going to click on continue. It's going to take a few minutes. This is where I'll actually be showing an already built version, because these things sometimes take a little bit of time. Okay, while that loads, let's actually jump to this tab right here. So this is actually some of the information that we would get once that finishes uploading. As you can see here, I have an image of every cloud that I've trained the model on. So the Cirrus, Cumulus, we have different photographs, not just a direct image of the cloud, but from a landscape, from different angles, because we know that we're going to be getting different images and we have to make sure the model is well trained. If you look over here, because I had labeled the images before in the CSV, I can now see that I have 20 images Cirrus Cloud, 20 images Cumulus Cloud, and Cumulus Cloud, right? Now, one of the great things about working with AutoML, let's say some of these images are mislabeled. I can actually select the image and assign the label myself. So actually, even after I train the model, if there were some errors, I can actually just tell the model next time, hey, I'm going to click on this image. This is the incorrect prediction. This should be this. So for next time, it's easier. When you're thinking about how we would have to do this without actually working with the user interface, we probably would have to open the image, make sure that it's the cloud that we expect it to be. But here with the user interface, we can simply just select and say, hey, this was actually the wrong one. Let me assign it a different label. So it allows us to actually just do this all with the user interface. And then what you would get at the end is this output saying all your 60 images are here. All of them are labeled. And if you have any unlabeled ones, you can do it. And then just using filtering options, you can filter out the unlabeled ones and pick them out, or filter out the name and say, and fix that as well. So it's a great way to actually start putting this all together. Let's see if this part's done. Still not done. What normally would happen now is you would click train a model, and then the model will start training itself. I'm going to hold off for this for 1 second to see if the other one's ready, because I don't want to spend too much time training, because it might take 30 minutes. All right, so in this case, what we would do now is we would simply click train new model. Once we click train new model, we're actually going to select the training method. So before, we had already told it's going to be image classification, because this model is already pre-trained. We've already defined it, but you can actually change it at this stage if it's the first one. A couple little different things you can choose, like when we talked about custom training, you can build your own custom model and give it a slightly different output. Edge is a little bit different, and AutoML, which is the one we're going to use. We then have all the details here, so you can give it a few more details in the model. So let me just go 1 second. Train the model. See if this one's ready. Not yet. And then you would start actually putting everything here. The one option I want to show is give it a different model name and the computing and pricing. So this is actually really important because now that we're working more on cloud, we know that we're actually renting resources from whatever our cloud provider is, right? We're no longer relying on my single Mac, which costs a lot of money, but is nowhere near as powerful as me borrowing 25 machines from Google Cloud. So what is Google asking for me here? Well, it's allowing me to have some control over the cost of my project, right? Funny story, in the company I used to work for before, we were working with text translation. And we were getting all these text files coming in. We would translate them, and it was fine. We were getting maybe like 5,000 lines of text. For some reason, one day we got about like 5 million, 6 million. This happened on a Friday. And if all of us are programmers here, and you know, never push anything live on a Friday. So don't push live on a Friday. So nobody, and I was actually involved in that project as well, so I take responsibility as well. But we were actually scanning with the Google Translate API. There's a free tier. We heavily exceeded that free tier. So on average, we had budgeted that we would spend about $200, $300 a month on using the Translate API. By the time we get there on Monday, we had already run up a bill of 5,000 United States dollars. So that was actually a very fun conversation with the CFO, explaining why in one weekend we have to pay a $5,000 bill, but we have to. So what's this option giving you right here? Well, you're saying your budget. Now you get billed per hour for AutoML. So however long you're running your nodes, that's how much you charges you. So obviously the more hours you're running your nodes, the more expensive. So here you can actually control how many hours you want to run the nodes in, so you never exceed your billing cost. This is actually great because not all the solutions in Google Cloud give you some sort of billing control. You actually have to build your own billing control involved. But this one is actually saying, okay, if you set your budget to 8, we're going to keep it as 8, and then they give you an estimated time of completion if you're going to work with 8 node hours, right? If you change it here, you'll get a different estimated time of completion. Well, in this case, no, because it wasn't a big deal, but you would have it here. Let's see if this one's done, not yet. So now we would actually start our training process. I'm actually going to give this one another second, perfect, because I just don't want to train a new model yet. Let's jump back here. Let's just do this very quickly. This is the new version, and let's set it to 8. And we're going to start training. So once you start training the model, you'll see that it's actually training here. If something's incorrect, it will actually flag it for you and tell you that you've made a mistake. One of the things.
During the training phase, how would it identify that you made a mistake?
Sorry?
During the training phase, how would it identify that there's something wrong with the data you're feeding?
Good question. So some of the typical problems you're going to get with AutoML is that the image is not clear. It's in a different format that it couldn't read. Those would probably be the ones with images. When you're working with tabular data, it's probably saying that there's a null in there, or in one of the columns that it recognizes as a numeric column, it found a string and doesn't know how to translate it. So it's going to be very obvious errors, not things.
Not really mislabeling, because it wouldn't be able to.
Not really mislabeling. So, but the output will tell you how accurate it was when there. So generally with AutoML, it will actually do about 90-10 split. So 90% of the training data, 90% of the data will be used for training, 10% will be used for testing, but you can play around with this and move it around. But one of the great things to do is that you can actually create a labeling task. And what it will do is that anything that it finds unlabeled, you can actually label it yourself. It'll label itself. So it will try to recognize, hey, I think this is that. And they'll label it for you, and you don't actually have to do it. So 60 images is not a big deal. But we were working on a project at Carrefour where we're trying to label some of the shelves. We needed maybe 300, 400 images per shelf space. So now we're talking well into the 10,000s of images that we're actually spending a lot of time labeling. So you can create a labeling task that will label things for you, but you would need some images labeled before. Obviously, it's going to make mistakes, but that's why you have the manual option of clicking there. So you had a question?
How do you know how many images do you need to upload?
That's a good question. 1 second.
I mean, the more the merrier, right?
Essentially, the more the better. What you'll probably do, if I will jump here real quick, is once you actually finish, you'll be able to evaluate your model. So let me share this tab again. So this is a pre-trained model for anyone didn't see me switch the screen. You'll see your evaluation data right here, and that's how you're actually going to determine it. So when the project I was telling you about in Qatar 4, we actually scored perfect, so we know we overfitted. We found that out very well, and that was with about 60, 78 images. Then we actually had to increase it to 200, 300, but generally the more the merrier. Now, question on the image cost, because that's something we always have to think about. Since you're using Google Cloud Storage, the costs are relatively cheap. I forgot exactly what it is, but it's like 0.020 US cents to store a gigabyte or 10 gigabytes, something like that. But there are options in cloud storage to actually even make it cheaper. So if you know you're only going to read these images once for training, there are different tiers. So you could give you the cheapest tier possible, which is half the upper tier's cost. So you can always make it more cost efficient if you need to store like 10,000, 30,000 images. I would probably say it depends. Like since here we're looking at 3 different labels, we probably want a fair representation of each one. So probably 7 images, 6 images is not going to cut it. We're probably going to be looking more closer, like in this model, 20 images each. But the more the merrier. But you want a fair representation. So if I had 200 images, but 150 of them are this cloud combination, it's not going to be very good for the other ones as well. So it'd be very good at predicting one, but not the other. So let me jump back to this tab. So you set the label names, what they could be. So just because I don't remember the name specifically, we'll do Cloud 1, Cloud 2, and Cloud 3. We delete this very quickly. And then we tell it how to label the images. So we actually have to write some instructions here. And then you'll be in the guidelines, and I'll explain that maybe after this one to not spend too much time on it, saying, okay, how do I recognize what kind of image is supposed to be? And you write some instructions. And after there, your custom labeler is ready. And any images you don't have unlabeled, 60 is not a big deal, but when you're looking at 60,000, it can actually auto-label them for you. And when you've realized you made a mistake, you will need the human person to actually make the adjustments for you. So our model is being trained. So let's go back one step. And you can see that it's now being trained, and it will actually give you the time it's taking to actually train it. So it hasn't uploaded it here yet, but what you'll do is you'll see here saying how often, how long it's being trained for. Generally with 60 images, you're looking about a 35, 34, 40 minutes. But again, it depends how much billing you put down and everything. If you want more computing power, it'll obviously be quicker. So it really just depends on the amount of data. So more data will actually take a little bit more time if you're using the same amount of computing power. So once your model is actually trained, again, so far I've done everything on a user interface. I now want to serve some predictions. So I'm actually going to go to the batch prediction option. I'm going to go through the step of creating new predictions. So I would give it the name. I will go cloud example number 5. Now, if I'm actually using a table, let me jump here to my clouds. Now it's going to ask me, where do I find these images for testing, right? So this is now what we're calling out of sample testing, right? It hasn't seen these images anywhere before. The output format is going to be JSON and ML, but you can play around with this. So what I'll do is I'll go to a cloud storage bucket, and I'll show you guys what this looks like in just one second. And I'm going to select this. And then the output bucket, which is where it's going to actually put the output file. I'll actually select this same bucket. I actually put it in test as well. So now I'm telling it where to find the images, and I'll show that in just 1 minute. And then here. So I'm going to create this, Cloud 5. Let's go back to this tab right here. So I created a file called test.jsonnl. And for the people viewing here, you'll be able to see what this looks like in just 1 second. and you will see that I put the path of the image here. Let me just move this to Google Doc so other people can see as well. So what the JSON.NL file will have something that looks like this, where I'm telling it where the content exists. So again, just a Google Cloud Storage bucket that I put my images in, and what type is the file type. So these are my test images, something the model has never seen before. And then from there, you actually can now start doing the predictions, and that would give you the output. So it's now running in the background. Now that it's running in the background, we'll go to a finished example. So I'll jump back here. Let's go one step back. Oops, sorry, not this one. And we go to, not this one either, 1 second. And then here's my predictions. And it'll print it out here. Let's open this file. And let's copy this and put it in my Google Doc. I passed it 2 files, and what you can see here is, looks a little complicated, but it's saying this is my test image, this is the IDs, and this is the confidence that I think it's this cloud type. So you can actually see here, very 99 that it was a Cirrus, a little bit, and then for this one's that it's not. So you can check now to see if it actually was that cloud type. So it basically will give you for each of the labels a confidence score, and that's the one you would select if that's it. So essentially, you can make this output look a lot prettier than what it looks like here. Once the model finishes doing its predictions, you'll be able to see how well it performed as well. But now we've done the step from training, modeling, and then predictions all inside a user interface. And going back here, I didn't have to write a single line of code. Now, after you've done you created your model, you can go to the models section, click evaluate, and then you can see how well the models perform. So if you look at the confusion matrix, we can see that it's actually not doing too bad on figuring out Cirrus Cloud, pretty good, but it's getting some confusion here where we're making some incorrect predictions. So we would maybe need to figure out what do we need to do with these two to actually make it a little bit better. Maybe too many high quality images of this one, and the image quality here is not as good. So again, you can also change your confidence threshold here to see how that would impact it. And then if you want to work with the code a little bit, you can actually switch your confidence threshold when you make the prediction with the model. Also with AutoML, you have the option to deploy and test. So you can create this as an endpoint rather than sending a batch prediction like I did today, which is I'm uploading a file. I can actually just ping the API with the image, and then it will give me the response back. So this is when we're trying to do something a little bit more online predictions. This will give me that option there. And then you get some more information about the model and its properties. So one of the great things about this solution, it took about 28 minutes to train the model. So I expect by the time I finish here, we'll have 28, it should be done. All this was done just using a user interface, and took us about 28 minutes to do it once it finishes. So one of the benefits that we see from here is that we don't actually need the coding expertise. And because we can evaluate our images and whatever data we're trying to predict, we can actually see, okay, is this ready for production? And if it is ready for production, just using the user interface, we can actually deploy a solution that can now be pinged by any app, phone, device, and just call that API endpoint, and it'll return back the prediction. So this is actually all something that is all available via user interface. And you can actually get a little bit more fancy with some experiments and stuff like that, but that's for a different day. So it's very powerful what you can do with this. And I can tell you that having now worked with a couple of multinationals that have done this, they are using AutoML to actually serve production-ready models that are actually impacting day-to-day activities for everybody. And being a coder, like when I first saw AutoML maybe 3 years back, I was like, this is great for testing and playing around, but we'll never use it really to deploy a model. It's always going to be in PyTorch, TensorFlow, but no, now it's getting easier and easier. So if you know the theory, maybe you don't need the technical side that well. Any questions on AutoML? Great. So let's now look into something a little bit more technically complex, BigQuery machine learning. So a lot of people tend to know SQL very well. You'll find a lot more people that know SQL versus Python and R and even more old school languages like Java and C++. And it's because we're all working with data now. So Bigquery ML is a way to actually build machine learning models just using SQL. No need to write any other programming language. It would just be SQL. So it gives the data analysts the ability to create these models, providing they know the theory behind it. So what we're going to do is see how that actually works out. And I can tell you that Bigquery ML is actually used in a lot of businesses as production-ready, to build production-ready models. So how do we work with Bigquery ML? Well, we're simply just going to write a SQL query to create the training data. We're then going to also use a SQL query to create a model specifying what model type we have. Now, obviously, we're not going to have the number of different algorithms that a scikit-learn would give us, but there's the major players are there: nearest neighbors, random forest, logistic regression, linear regression. If we want to do recommendation engines, we do have the option of matrix factorization. So these options do exist in Bigquery ML. And if you want, you can actually build your own custom model and deploy it in Bigquery ML. So you can get the data scientist to build the model stored in Bigquery ML, and then the data analyst can run its predictions or build different training data on it. It will also give us the ability to evaluate a model, again, also just using SQL. And then it will allow us to create predictions with that model, again, just using SQL code. So when you actually look at the syntax and the language, it's going to be super simple to understand, that anybody with SQL knowledge will be able to understand it. And again, it gives them the ability to build their own models without always having to rely on a data scientist. So if we look at very simple, what it would be like, first step, just like before, just like I showed in the first slide, we have to train the model, right? So this would be essentially our query to extract the data. This would be our query to create the model, and we'll go into a lot more detail in just a minute. And then if we just focus on the top part, this is just a standard query that we're all probably very used to. We can see that it's saying create or replace a model. I'll go into a lot more detail about what this is in just a second. But now this is a query we would use as a template to create a model. Then after we create the model, we run this query to select star, ML evaluate the model we want, and then we'll get a similar confusion matrix like we did with AutoML, and then our key performance metrics for the model. And then finally, we're ready to actually demo. So let's jump into this project right here. What I have here is a simple query editor. If you haven't worked with BigQuery before, like I said, is Google SQL Data Warehouse solution. The model of BigQuery is double the data, doesn't mean double the time. So if I'm querying 10 gigabytes of data and then my next query is 20 gigabytes of data, actually it should run faster, because what BigQuery will do in the background is give you more resources. It's all actually allocated by Google, so you have no control of how many resources you would get. You don't pay more to get more. It would say everybody would essentially pay the same price. I will put a little bit of an asterisk on that, because there is a way you can actually get more resources from Google. But then at that point, you're really talking to a Google salesperson to buy more, what they would call slots. And you can then get more computing power. But from the user interface, you actually have quite a lot of power. So if we go here, let me just close this tab at the bottom. We're going to start with our training data. So the problem that we want to solve first is, will a user come back to buy a product? So I'm going to actually just open up one of my training queries. I'll zoom in a little bit. Great. So I'm actually going to get data from a public e-commerce website. This contains information about how a user has interacted with the site, so bounce is time on site, and we're going to actually use that data to help train our model. And our dependent variable is going to be if they're not a new visitor, will they come back and buy the next visit? So what are we trying to predict? Depending on how good their first experience was, do we think that they're going to come back and buy the next visit? So if we look at the query steps, let's start from the innermost queries. Select, just like any SQL practitioner would, we have a full visitor ID to identify that user, and then we're just going to put an if condition right here that's going to return 0 if they're not going to return to buy, and 1 if they're going to return to buy. And then if it doesn't have an option and it can figure it out, I'll just put 0. Just like any SQL practitioner would do, we select our table. We're going to do a join, because this is right here our dependent variable, right? And this is going to be our independent variables that are going to help train our model, bounce rates and time on sites, and obviously full visitor ID to join the data. So we have our features, and we have our label, and here's our training data.
So what exactly does bounces over here?
Good question. So in e-commerce, the bounce is when you land on a site and you don't do an interaction, you just leave. The way most e-commerce analytics works is that if you land on a site and you do an interaction, like you favorited something or you played a video, it wouldn't count as a bounce. A bounce generally is considered not all. Yeah, like a non-interested user, like the site wasn't engaging or the app wasn't engaging, they just chose to leave. So it's generally what you don't want, but that's not always the rule. Sometimes a high bounce rate can be good depending on what you're trying to do with your site. So this is essentially a query that's just going to prepare our training data. You can run the query and save it as a table, which I did do actually right here. Scroll down. So what I did was I saved the query as a table, so I can then just query this table and not run the query. Without going too much detail on Bigquery, Bigquery charges you for the amount of data you query. So if you're querying 32 megabytes of data, it's going to be cheaper than if you're querying 100 megabytes of data. So if I actually save a table, this table size is actually going to be very, very small, 60 megabytes of data. So now because I saved it and I'm not querying from the source, which is this table right here, it's obviously going to be smaller. So I'm basically at just half my cost. So that's one reason why you might want to do it that way. Now, what's the great thing about Bigquery Ml? Well, let's look at a creator model query. Let's break this down into a couple steps. At the very first part, we have create or replace a model. So what we're doing here is that we're just giving it the model name. So the first step right here is actually the data set where our model is going to exist. So I called it BQML tutorial. Then it's just the name of my model. So after the period, it's just going to be the name of my model. In this case, I'm just calling it classification model. Then I'm going to go into the options clause, which I'm going to tell it what type of problem it's going to solve. So I pick logistic regression, so it knows it's going to be a classification problem. And then I tell it what the label is going to be. This is important. The name of the label has to match the name of the data set. So if it has a slightly different name or you added an extra T, it's not going to work. Then you close your options clause like you do here. And then you do as basically just creating a subquery here. And then you can actually put the same training data I showed you before. This is exactly the same. Or you can tell it to do a select star from the table you created. Kind of up to you of how you want to do it. And then from here, you run and create your model. I'm just going to call it model 3 because I already have that model created and in case something goes wrong. So let's give this model a couple seconds to see how fast it's actually creating the data for. Let me zoom out a little bit. So while that runs in the background, I'm actually going to show you 2 created models. So the first one is called classification model 1, which is the same exact query I just ran. And this is the details you will get on the model. You will get the model ID. Let me zoom in a bit. The model ID, when it was first created, when does it expire? So you can actually set your model to expire because the longer you keep in Bigquery, it'll charge you, but it's very cheap. It's like 10 cents per 10 gigabytes or something like that to store it there. The last time it was modified, what model type is, the location of the data, and the evaluation metric, which would in this case mean log loss. Then you'll see some of the training options that we didn't go into a lot of detail with, but these are some of the things you can add in BigQuery. How many iterations? By default, it's always going to max it out at 20. If you need to add any sort of regularization, if you want to do early stopping, you can actually impact the learning rate as well. So all this information will be there. If you click on the training option, you can actually see the training loss and evaluation loss pretty much neck and neck. So this is not actually very good. But then you can see at each iteration how long it took for that particular training iteration. So we set a maximum of 20. Doesn't mean it'll use all 20. After it realizes that it's not improving because we picked early stopping, it will stop right there. You can actually see the learning rate at each iteration as well. You can actually influence the learning rate yourself. You can actually lower or increase this if that's what you want to do in BigQuery ML. It's up to you. So you can give it like a range of where to play around with the learning rate.
I'm sorry, this might be a question, but why would anyone do it?
Not exactly too short because it'll actually just make it slower, but maybe for some reason they want to see what a lower learning rate would do, see if it takes longer to find the minimum. But yeah, essentially you can play around or increase it if you want. I mean, you'll jump probably the minimum, but the interesting thing about BigQuery is that it actually makes a lot of good decisions on its own. The main problem I found with it is that particularly when you're running into very data sets that don't have a fair balance of the classifications of different labels, it can actually be very difficult. So you have to play around more with the data set rather than adding any sort of hyperparameter tuning.
That was actually a quick question. How much control does it give you? When it comes to things like hyperparameters.
So there's to answer that question. It depends on the algorithm you get, and but not as much as you would get on SQL. But it depends on like a scikit-learn. But it depends on the algorithm you choose. Some of them will give you a few options. So I'll just share this tab real quick. And this is actually the documentation for BigQuery ML. So these are the model types that you have available to you. So if we just ignore those for a second, these are generally the type of hyperparameters you can tune. So obviously when we're doing a decision tree, we'll have to name the number of trees, but you don't get that many hyperparameters as if you would. And as you can see from above, there's not a large amount of algorithms that you can choose from. So we don't see, there should actually be a random forest in here, or maybe they changed it from the last time I saw it, but you wouldn't see every possible algorithm that you can get. But just like AutoML, you can actually build your own on TensorFlow and then implement it on BigQuery. Yeah. So generally this is about as much hyperparameters as you can tune. You can't really do much else besides what options they give you here. BigQuery also gives you a forecasting solution, but we could talk about that another time. So we go back to this tab, and now let's look at our evaluation of the model I had created before. And we can see right here the ROC curve, not that great, but one thing that we can do is we can actually play it. Let me just zoom out a bit. We can actually play with the positive class threshold to see how that impacts it. So you can actually set the positive class threshold in BigQuery when you train and replace a model. So if you know, hey, I need to set it at 0.02 to get a better ROC curve, then you can actually set it there. And then you have your confusion matrix like always. Again, if you play around with the threshold, it will also impact all the metrics, including the confusion matrix. So depending on what you want, higher precision, higher recall, you can actually say how you want it here. So this was the model we created earlier, just now. And let's see, generally started GMT time. So it didn't take too long to create it. I would say under like 2.5 minutes, something like that. Sorry, under 5 minutes, something like that to actually create the model. So very quickly we created a model, but let's do a quick evaluation. We know we're actually not doing too well. So this is probably a little bit unacceptable. Now, one thing that we can actually do with BigQuery is we can actually improve it, the model, by providing a better training data. So if I just do a very simple evaluation of the model I just created, I just gave it a simple score of saying, okay, if it's under 0.7, under 0.8, it's actually not great. So now using the model evaluate metric, I just put it in a nicer way rather than getting the F1 score and everything that we just saw there. So if I wanted to add more features, and since we're almost out of time, what I did was I actually just added more features to help the model because I saw that the evaluation loss and the training loss was almost identical. So what I did was I simply created a new model with those new features. And then from there, I created what I called my classification model 2. If we look at the schema, I actually added all these additional features that were not there before. I can share the query with you guys later, but we only have 4 minutes left. And you can see that I added number of page views, source, how the user got to the site, medium, what was the medium if they use organic search, paid search, the channel grouping, the device they were using, and the country. And then from there, if we look at the evaluation of this model, simply by adding features, we can see that we got a better ROC curve. Let's see exactly what's the best threshold right here. About there, better ROC curve. We can see that our accuracy is 98%. ROC curve is 92%, better than the 76 we had before. And if we look at our confusion matrix, still not perfect, but 80 to 85%, we're getting the true predictions, and then our false rate is acceptable. Really depends on exactly what the problem you're trying to solve, but let's assume we're just trying to predict who's going to buy, who's not going to buy. In the e-commerce world, this is very acceptable. And like I said earlier, these are actually ways that we would actually deploy models live. Why did we choose to actually do this way in some of the companies I've worked in? Very simply, it's because we know that the training data is the most important piece of the puzzle. Generally, it's the most important piece of the puzzle. Mm-hmm. And a lot of times I get the training data from a SQL data analyst who spent hours and hours reviewing everything. So they probably know more about it than me. So here they can actually just create the SQL query themselves. And then normally they give it to me, but now they can actually be part of the process of building the whole model themselves. And then they can play around and say, okay, these 5 features did not work. Let me try to change this a little bit, see how it impacts. And then it can actually get to me, and then I can actually deploy it. So once actually this model is created, just like AutoML, you can actually ping it, and then it will serve your prediction. And then the final thing I wanted to show was just running predictions. Oh, I can add 10 minutes, perfect. So this is great. The final thing I want to show is I wanted to show you how you do predictions. Very simple. You just do ml.predict. You point to the model you want to use. I want to use classification model number 2 because the model number 2 performed better than model number 1. And then I just write my query underneath of where it's going to get the new training data. So obviously I'm giving it data it's never seen before. So I write my query. Again, if you create a table, you could just point to that table. And then you run your predictions. And once you run your predictions, let's see what it looks like. What you're going to get is here you have the same features you use to train the model, your unique session ID, which will help identify the user. And then here it's saying that that it predicted this user will convert on their next visit because it's a 1, 0 would be no. But here's a great option of it because we're using logistic regression. It gives you the probability that it was a 1, probability that it was a 0. So we see this one was very, very close. In the e-commerce world, if I'm trying to do a paid ad campaign on this, I might say, okay, this user is way too close. Maybe I want to focus on users that had a higher likelihood of being converters. So in this case, it's a better representation. So these guys are very highly likely. Normally, what actually I would do at this stage is I would actually bucket these users. I would say anybody 70 and above, highly likely to convert. Anybody, say 40 to 60, medium likely to convert. Anybody below 40, less likely to convert. Because you don't actually want to ignore these users. You just don't want to maybe spend too much budget on those guys and girls because they're not worth the extra effort. So again, all this was done just writing SQL code. No need to write any other language. And almost everything was done in one platform. You do actually have to ping it, which means you would have to work with another BigQuery product. But the aim is, if you're a SQL practitioner and you've always wanted to go into the ML world, BigQuery ML does give you that option. And you can actually build some very impressive things with this. And as I showed in the documentation before, it doesn't just stop at classification. It goes to forecasting. It goes to recommendation engines as well. And I do know one large I guess, film company, a film streaming company that does use BigQuery to make recommendation engines. And the last thing I'll add in terms of cost, just like every Google Cloud product, you pay for what you use. So if our model was only 10 megabytes, and we can tell that by the detail, you would actually only pay for that much there. So whatever the size of the data you're querying is how much you would pay. So you can actually make this very, very cost effective. And I guarantee everything we did now has not even got to $1. So it is pretty impressive how to do it here. And hopefully you guys can see that, and anyone listening on the online, that you don't actually need to have deep technical programming knowledge to build some very sophisticated solutions using AI. And it goes even beyond this. You can even call some of the APIs, Vision API and Translate API, from some of the solutions I showed you guys here. And that's about it. And hopefully you guys found it useful, and let me know if you have any questions. Yeah.
Okay, so one, you made a throwaway statement, something about the training rate and the evaluation rate being too similar, and that was a bad thing. I didn't really understand the implication of that. If you
Well,
wouldn't mind elaborating.
Yeah, what I was saying is here, when we go to classification model number 2, where is the training? So the log loss was like essentially right on each other, so essentially perfect, right? It's not necessarily a bad thing, but I would almost be wondering maybe if there's any issue with like over 15. Now, the thing is, this is in sample training, right? So it's data seen. I would probably want to do it without a sample. So what I would do with my predict, when I run my predict query, I would actually see, okay, with data it's never seen before, how well does it perform? And if I use like historical data that is never seen before, I can compare, does this user really convert or not? I mean, this is actually pretty good, but I would have a little bit of suspect saying this would be this well in the real world.
Right. So it's, what makes it suspicious is the fact that it's too good.
I would say it's too good, and it's probably not going to happen.
Got it. Okay, fine.
And
I was wondering why that was a bad thing, so that's what threw me off, but I get it, yeah.
so I will say in the e-commerce world,
This is what an ML engineer dreams of.
yeah, if I could get it like this every time, I mean, I would try to predict the stock market. But no, generally in the e-commerce world, the data is very, very messy. So like, I mean, I think anybody would say that you spend more time pre-processing, but e-commerce, like one example I always give is I used to work with a gaming company. You get on an airplane, you lose your Wi-Fi, and all those interactions are happening, right? So eventually all that analytics is going to be batched and sent to you once you connect to Wi-Fi or 4G when you land, right? But there's going to be missing data in there. This is more of a data engineer problem, right? That missing data is going to then show incomplete on my analytics platform, which is where the data I'm currently using to train my model. But my model is not going to realize that. So web and analytics data is very messy. Another good example is, a lot of people think time on site and is a good indicator of engagement, right? You're spending a lot of time on the site. I always say it should be active time on site, but because you can measure that in different ways. But if you just look at time on site, which is one of the features we use in this model, the big problem with time on site is, let's say I'm going on an e-commerce website to buy shoes, and the model thinks it's a very important feature. Suddenly my best friend starts talking to me and we go grab a coffee. The site's still open, but I'm not interacting. So it might start, and then I buy it maybe 25 minutes later. It might be thinking, oh, well, the more time on site, better is the person to convert. But that had nothing to do with it. I was out getting a coffee. So you need to maybe think about some of the things like that would impact it. Clicks. There's a good metric called active time on site, which is, it stops measuring time on site if it doesn't see a mouse movement or anything playing. No scrolling, exactly. It'll pause it and say, after maybe, let's say, 1 minute of inactivity, it'll stop the time on site because maybe you're watching a video or something like that. And I guess if you guys like, you've seen it a lot with Netflix, right? Like, are you still watching?
Yeah.
Yeah. So like, they want to know if this content is still pretty good, right? So probably to stop showing it to you, but also, maybe they're feeding that to a recommendation. And yeah, he really liked this. He really liked this content, and obviously because they can't be looking at your eyes in the camera, to see if you're actually looking at the content. Not yet. Well, legally, nobody should be doing it. Yeah. I mean, there probably is going on, but yeah, e-commerce data is a bit messy, so I know that won't be it. But it actually goes into, and this is why it's great that these solutions are coming out, because, like I said, the data analyst knows the data very well. There's insights that they have on the customer that I would never know. One of the things about Credit Flow that I find interesting is what the customer likes to see in the store. That's usually something that I don't really get in some sort of quantifiable format. But when I speak to the analyst or the product specialist, they're like, customer really loves to see this, like that. And that's something we can take into account in our models. Also, you're saying like the bigger the brand logo, they really like to see that. But generally, there's no metric that we measure. Oh, how big did this coffee company put their logo, right? But they start telling us these things that would be interesting. So they spend so much time looking at this data, whereas my time, I'm responsible for making sure the models are working and deploying correctly. But they know the customer very well. And now we're giving them the opportunity to start building their own models. And then they work a lot more with the data scientist and the ML engineer together to build better performing models. And at least for kind of 4, I would say for sure, without like two data analysts in specific, we wouldn't have done so well. Sorry for a little bit of a brag, but we did this case study with Google on selling ads on the site that is published with LinkedIn. If you look at Google Cloud and Google Ad Manager page, they put it there. We worked a lot with the analysts to actually understand what made the ad successful. Why did people like those ads so much? And and that's something probably I didn't have enough time to figure it out. And either way, they had 2-3 years of experience of working on that side that they were able to give us. And in fact, they actually built some of the query for us. And then we use that in our model. Auto ML as well is also a great solution. There's actually some solutions. If you guys ever go to Mall of Emirates or City Plus store, fully automated AI store, there are some testing solutions in there that where we use Auto ML to actually figure out what the image is supposed to be like that the user is seeing. So it's very impressive what you can now do without having to write a line of code. And I did just tell this to some of my junior team when they're saying, "Oh, do you think we'll ever become like obsolete because now it's becoming so much easier to build these models?" I said, "No, because somebody needs to build the product that runs in the background of this. So there's always going to be that next thing that you will have to develop." But I like that we're making AI more available to everybody on our teams, and they don't always have to, write me a ton of tickets saying, "Can you build this, this, and this?" They now have the capability to build it themselves. Cool. Any other questions? No comments. Well, let me see comments. Oh.
Based on what I've seen and heard in my experience, there's this shift towards NoSQL databases as opposed to SQL databases more. So is there any plan to include that functionality as well, or?
To the best of my knowledge, no. Like, at least I haven't heard anything about that. But I wouldn't be surprised if that's somewhere in an alpha product or something being developed. I can definitely tell you they're making it easier and easier. How many people here have worked with TensorFlow? Okay, like you remember like TensorFlow like 1.0 and everything, where you actually had to like create. Yeah, so you had to create like a session, and then you had to define the variables, and they were placeholders. And then when you actually start to put data in that variable, you have to run it there. Now TensorFlow 2.0 with Keras, I mean, it's just.
I think that's the only one that I use.
Yeah. It's becoming easier and easier, and you're going to start to see with that. I think it's going to become a lot easier. And there's other solutions in the market. Like, does anyone ever here work with Data Robot? No. Check it out, Data Robot. Yeah, like I would check it out. It's a way of building AI solutions without having to write code in either. And they do a lot of interesting things. Some limitations that I wouldn't be a big fan of using it, but. I do see the value of it in the long term. And I think you're going to start to see a suite of products from Google to become easier and easier to build these solutions. Right? Yeah.
Discussion after the.
Oh, sure. No problem. So. Okay. Perfect. All right. Thanks everyone for joining online, and. Yeah, please feel free to reach out if you do have any questions. All right. Let me stop sharing the screen. and I'll leave the studio. Bye.